Our first topic in pre-calculus is about conic sections. What is conic section? Conic section is a figure formed by the intersection of a plane to a right circular cone. So depending on the angle formed by the plane with respect to the cone, a conic section, circle, or ellipse, or parabola, or hyperbola are produced. So for the first starter, we're going to prove first the circle. Okay, a circle has standard equation of x minus h square plus y minus k squared is equal to r square. H and k stand for the center of the circle and r stands for the radius of the circle. Okay, how are we going to prove this standard equation if this is really true? How did they arrive with this? So that's what we are looking for. So we all remember the Pythagorean theorem. What is Pythagorean theorem? It utilizes a right triangle. So this is a 90-degree angle. And we always use C as the hypotenuse. This is the A and this is the B. So we're not more particular with the use of the letters, but we are already familiar with the use of ABC in our triangle. So C being the hypotenuse, and this is always the longest side. So how do we solve for the longest side? It is the square of the longest side is equal to the sum of the squares of the two sides. Okay, so we have to remember this because we are going to use this to prove this standard equation. Okay, let's go back to the circle. As it says here, a circle has a center with coordinates of h and k. So don't get confused because h and k is also x and y coordinates. What is our k? It means coming from here up to this point, and this h is up to this point, meaning this is the h and this is the k. Okay, as it says here in the definition of the circle, from the center to any point of the sides of the circle, it produces a radius. So no matter where we extend our line coming from the center to any point, all of those are radius. So let's utilize one point here. So we produce a radius. So what are the coordinates of the point here? This is x and y. Okay, how are we going to prove this standard equation? So let's try to make also a right triangle because we are depending on the Pythagorean theorem. So let's try to produce a line here and another straight line here. Okay, let's try to move this longer. Okay, were we able to have a right triangle? Yes, here and this one. But how are we going to find for the length of this and the length of this? Okay, how are we going to do that? Okay, if this is our coordinates h and k, therefore this is what? The k. How about this one? If this is h, this is h. How about this one? From here to here is what we call x. Coming from 0 up to this point is the x. Coming from this point up to that point is what we call y. And coming from here up to this point is what we call the h. And coming from here up to that point is x. So if this is the y from here and this is the k, how do we solve for this point? This point, or this line rather, minus this line is equal, right? So this is also the k. K, they are equal. Therefore, y minus k is the distance of this. Okay? How about this one? This is the only thing left. We don't have a measurement of this. So this line, which is the x, minus the line h is equal to x minus h. Get it? Okay, from this, we were able to produce a right triangle. So this is the r. This is what? Y minus k. And this is x minus h. Okay, let's go back to our Pythagorean theorem. The c and the r are the same. Therefore, r squared is equal to a squared. A is equal to x minus h. Therefore, this is x minus h squared plus the b squared, which is our b. Y minus k. Y minus k squared. Are they the same? Yes, definitely. Therefore, we were able to prove the validity of the standard equation of the conic section circle by means of Pythagorean theorem and by the use of the circle in our Cartesian plane.